In this short video, I'm going to be quickly reviewing consumer and producer surplus. These are concepts that we're going to be using to analyze a wide variety of problems later in the course. So we need to make sure that everyone is on the same page and is able to solve for consumer surplus and producer surplus using equations, not only graphically. So first of all, a quick review. What is consumer surplus? Well, consumer surplus is the benefit that consumers get for being able to buy the item at the market price. So for example, if for some item I value the item at $10, $10 is my reservation price, or the price if I paid that would leave me indifferent between buying and not buying. So if I value it at $10, but the market price is $5, then I get $5 of surplus for being able to buy it at that market price. And we can illustrate the consumer surplus in the market. Okay, let's try that again. So here we have our normal graph where we have price on the vertical axis, quantity on the horizontal axis, and I'm going to draw the inverse demand curve for whatever item we're looking at, whatever market it is on this graph. And I'm also going to draw in blue the market price, and this is supposed to just be a completely horizontal line, my drawing skills notwithstanding. Okay, so let's say, for example, that I am the point who is represented at this highest point along the inverse demand curve, and I valued at $10. Okay. Another way of illustrating my surplus is it's a rectangle with a width equal to the 1 unit that I'm at least initially buying, okay, and the height of this rectangle here is the difference between my reservation price and the market price, which in the example I gave a minute ago was $5. Okay, so to get the area of this rectangle, we're going to multiply the $5 times the 1 unit that I'm buying. So 5 times 1 is 5. And this represents a consumer surplus that I am getting, $5 of consumer surplus. There's someone else represented at the next point along this demand curve, and they might have a slightly lower valuation. Okay. If we again make a rectangle that's 1 unit wide and has a height equal to the difference between the second person's reservation price and the market price, the area of the second rectangle will be the consumer surplus that that second buyer gets from being able to buy this item at this price illustrated in this graph. Okay, and so on. There'll be a bunch of other people with these similar consumer surplus rectangles and so on. If we add up all of those rectangles, that gives the entire consumer surplus in the market, which is approximately equal to the area below this this inverse demand curve and above the price. So it would be this area here. Okay, so we could calculate consumer surplus by finding that area. Similarly, suppliers get surplus. We call that producer surplus. Okay, so let me start by drawing the inverse supply curve. Actually, I should have it go through equilibrium points so that the price reflects equilibrium between demand and supply. I will write this as supply. And similarly, this the supplier, or the lowest price supplier, has some reservation value, the lowest amount they're willing to sell the item for that first unit that they produce. Right? And if you take the height, the difference between the price and their reservation price for that item, and multiply that by this width of 1 unit. That would get the producer surplus that the producer gets from selling that first item. Okay? And similarly, if you add up the producer surplus for all these different units, it is approximately equal to the area below the market price but above the inverse supply curve. Okay? So this suggests that this graph might be a starting point for solving these problems mathematically, and that's exactly what we're going to do. So let me actually clear the canvas here and draw some of this again, get rid of some of the clutter. So here we have our standard graph. We're going to have price on the vertical axis, quantity on the horizontal axis. Let's draw the inverse demand curve in blue and the inverse supply curve in red. Okay. Now, the total surplus, if we look at the consumer surplus plus the producer surplus, is equal to this entire area below the inverse demand curve but above the inverse supply curve. Okay. Now, in some problems, finding this area is rather complicated. You might have to use integration. But in the problems that we're going to look at in this class, we're going to assume that inverse demand and inverse supply are both straight lines, which implies that this area is a triangle. It's an area of a triangle. And we have this nice formula for triangles. The area of a triangle is simply equal to 1/2 times the base of the triangle. Actually, let me do this in purple. Times the base of the triangle times the height of the triangle. It's basically, you know, the triangle along one dimension, the triangle along the other dimension. We could call this the base of the triangle, and actually I reversed this. This the height of the triangle. Colors are reversed, but it's the basic idea. Okay, so the point is we want to find this distance, this vertical distance illustrated by this purple part right here, and we want to find the horizontal distance of this triangle here. Okay. Now, the way we find them is by using the meaning of this graph. So this point right here, the height of this point on the graph, is called the demand choke price. That is the lowest price such that the quantity demanded is equal to 0. So I can say demand choke price. Okay. And this, the height of this point here, where the inverse supply curve intersects the vertical axis, is known as the supply choke price. It's the highest price such that the amount supplied is still 0. Okay, so we simply have to find those two values to get this, the value of this this height here, the height of the triangle. And to find the width of the triangle, or this part illustrated down here in the orange, it's simply equal to the equilibrium quantity, Q star, minus the quantity, at this point on the graph here, which is 0. So the width of this triangle, this sort of part illustrated by this orange part, is simply equal to the equilibrium quantity. Okay, so solving this problem simply involves finding all of these different values. And so we can go through a sample problem. So let's just try one to go through this. So let's assume that the quantity demanded is equal to 152 minus 20 times the price, and the supply equation is given by 188p, 188 times the price, minus 4. Okay. So the first thing we're going to do is we're just going to find the demand choke price. That's the height at this point here. That's the price, or the lowest such price that the amount demanded is equal to 0. The way we can solve for that is we can just set demand equal to 0. So the quantity demanded is equal to 0. And we know from this equation that the quantity demanded is equal to 152 minus 20 times the price. Okay. So if we were to add 20p to both sides and then divide by 20, we would get that the demand choke price is equal to 7.6. So we can add that to the graph here. Okay. And next we want to get the supply choke price. We can do the same thing. We can find the price such that the amount supplied is equal to 0. So let's set the supply equation, or supply equal to 0, and we know from our equation above that supply is equal to 188p minus 4. So what we could do is we could add 4 to both sides, divide by 188, and we would get that the supply choke price is equal to about 0.02. Okay. So now we can put that on the graph here. So now we have 0.02. Okay. And the last piece of information we need before going to plug these into the area of the triangle is we need the equilibrium quantity. Okay, so to get that, we're going to set quantity demand equal to the quantity supplied, where the quantity demanded is equal to 152 minus 20 times price, and the quantity supplied is equal to 188 minus 4. Okay. If we were to subtract 152 from both sides, oh wait, let me erase. There's one mistake here. This was on the supply is equal to 188p minus 4. Okay, so instead of what we want to do is we want to then add 4 to both sides and add 20p to both sides, which would give us 156 is equal to 208 p, or the price is equal to 3/4, or 0.75. Okay, now we don't actually want the price, we want the equilibrium quantity, so we could plug this price into either the equation for demand or the equation for supply. Either way, we should get that the equilibrium quantity in this problem is equal to 137. So we can plug that in here. Okay, so now let's go back to this area of the triangle. So now to get the total surplus, consumer surplus plus producer surplus, we're going to plug in these quantities here. So the area is equal to 1/2 times this vertical distance here. Okay, so that distance is equal to the demand choke price of 7.6 minus the supply choke price of 0.02. Okay, And then we're going to multiply that by the width of this triangle, which is simply equal to 137. And if you were to simplify that, plug it into a calculator or Excel or something like that, you would get that it's equal to 519 and about 23 cents. So we can add a dollar sign here. So this is the total surplus in this market. So just to quickly review, we knew that the area of the triangle was 1/2 times base times height. So we had to get the height of this triangle and the width of this triangle. The height of this triangle is simply equal to the demand choke price minus the supply choke price. And the width, or the base, was simply equal to the equilibrium quantity in this market. We could then find the values of all three of those things and then plug them back into the area formula for a triangle. And that gives us the total surplus in this market. Using similar strategies, although not exactly identical, you should be able to find the consumer surplus and the producer surplus as separate things, not added together as separate amounts. So this ends this first short lecture. In the next one, we will talk about some government interventions, and we'll look at how that impacts consumer and producer surplus.